back. So in the previous lecture, you saw the employee class, okay? And I hope you have had time to run this module, all right? Employee class. Try constructing an employee TED, first name, middle name, last name, date of joining, and annual income, okay? Try this yourself, guys, okay? So to summarize, what have we learned so far? The keyword class declares the definition of a new class. The subsequent identifier employee, class employee, is our choice for naming our class. We could have named this employee first draft and so on, okay? The colon marks the beginning of the block of code that serves as the body of the class function. So after colon, everything else is body of the class function, class definition. Therefore, all of these guys are indented. The first method is named double underscore init double underscore. Informally, this method is referred to as the constructor. Its primary purpose is to establish initial values for the attributes of the newly created object. So what is the purpose of the instantiator or the constructor? It gives you initial values to our instance variables, okay? Instance variables are attributes. The implicit parameter self serves internally to identify the parameter instance being constructed. Now, other methods are defined following the same syntax as definition of functions, okay? Some methods are accessors. So this get name, get date of joining, get annual income, these are accessors. These access the state information of the instance. Some methods are mutators, okay? So new annual income, if I invoke it, if I say self dot annual income equals this instead of new, that would mutate self dot annual income, all right? So we will see some more mutators soon enough in other examples. Right now there are no mutators. I only have accessors here, all right, in my class, employee class, okay? Now the main example, a fraction class. You see, before going to the fraction class, which is a beautiful class, it is an immutable, that is, it is not a mute, you cannot mutate any of these variables in fraction class. I would like us to see the classes defined in the file point classes. Open point classes yourself. And these are examples from the sections 6.1 and 6.2 of the textbook. I told you about the textbook, sections 6.1 and 6.2, okay? Again, I will repeat myself. Please take some time to read these two sections. They are beautifully written. What I will offer here is a summary of those two sections, okay? So now we'll spend some time understanding the two classes constructed or defined in sections 6.1 and 6.2. So here, this is my example file and this is the point classes file, okay? So let's define a point, okay? To begin with, I don't know what a point should look like. I know there are x coordinates and y coordinates to my point, but for the time being, let me define the class point simply as class, name of my class, colon, pass. If you remember, what does this do? I've saved it. When I run it, All right, it compiles. All right, so right now I can say point is, P is point. What is P? It is a point object. I don't have anything more. I don't have anything else about P. So say I want X coordinate. 1_ means protected variable. 1_ is 5. P dot underscore Y. So that's my Y coordinate. That is 6. So what is now dictionary for P? Okay. X coordinate is 5, Y coordinate is 6. That's all it says. So good. I constructed my first simple point. Let me improve my class. Okay. Let's take time to read this material as we go along. I've tried to summarize what's in the textbook in those 2 sections. Here. Now, instead of individually defining each X and Y coordinate for every point I construct, I will get an instantiator to do all that work for me. So instantiator or the constructor method, it is defined _init _self. This is a special method. When you have double underscores, that such methods are called special. You will see what's special about such methods. Okay. Now, self dot underscore x is 0. Self dot underscore y is 0. In other words, I'm not giving it any x and y coordinates. My x and y coordinates are 0 to begin with. That's my setup right now. So these are my attributes. Note, these are protected attributes because it's only one underscore. Okay. No underscore at the beginning makes the instance variable public. Okay. 2 underscores at the beginning makes the instance variable private. Now let me read some more what I have written here. The method declaration begins with the keyword def, followed by the signature and then the function body. So this is your signature, this is your function body. The self parameter in the formal signature serves internally to identify the particular instance being constructed. So you are probably creating 2 different points. Different points have different x and y variables, but you could have 2 objects with the same x and y coordinates as it stands. Okay, so this is tricky. I hope you understood what I just said. So there may be different instances, each of which will have its own state stored in memory. We write self dot underscore x is 0, self dot underscore y is 0 to establish their initial values. Absence of self in the identifiers will make the identifiers local. If I did not have self, then these variables will have only local scope. The information cannot be accessed outside the method. All right. Not an attribute. So anything that's local is not an attribute of an instance. Okay. So let's run this or save this first. Now run it. Let me now create point P. So I've constructed. So you see, I don't have any parameters here written after self. Look at the dictionary for P. So P already has a variable underscore x and a variable underscore y, and they are both valued at 0. So this is essentially the point 0, 0. Where does P live? P is stored in this information, in this location. Now let's say Q. Okay. Now where does Q live? It lives in some other location. You see, in these are locations where our objects are stored in our CPU, mind you. All right. But what is the x coordinate for P? 0. What is the y coordinate of P? 0. What is the x coordinate of Q? 0. What is the y coordinate of Q? 0. So mathematically they are one and the same points, but not for Python. These are two different objects living in different locations, you see. So that's what I was trying to say. Okay. So these are just values which we will change later. Okay. So this is just a starting point for my construction. We will change this in our next examples. Okay. You will see in a minute. So I think my video is getting a bit too long. I'll come back to the rest of this in our next video. Until then.